Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Newcomb joins me. We're going to be talking about the Village Telco project, which is bringing low-cost data and VoIP to developing countries all over the world. You're going to want to see this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by Cachefly at CACHEFLY.com.
This is FLOSS Weekly with Randal Schwartz and Newcomb, episode 196, recorded on January 4th, 2012, Village Telco. This episode of FLOSS Weekly is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. It's time for FLOSS Weekly, the show about free, libre, open-source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the small projects you might not have ever heard of. So I really appreciate the opportunity to be able to do this show and bring you all these great projects. Once again, I'm back at my secret underground lair in Culver City. You may recognize this location. And also, if you're watching the video, you might see that the beard is now a goatee. As from 2 weeks ago, I shaved off the sides. I'm thinking about still keeping it. Let me know what you think if you're watching the video, or let me know if you're not watching the video. How would you know then? Anyway, so let's also bring in our co-host for this week, Newcomb. Welcome back to the show.
Hey, thanks, Randal. Good to be here.
Great. And although we were next to each other a few weeks ago, we're both via Skype back to the cottage this time, or back to the brick house, huh?
Yeah, I had to come into work today, so I'm here in the Oracle offices downtown San Francisco. So you can see the Transamerica building over my shoulder and the Coit Tower here in the background. I'm in one of the executive conference rooms, so I had to beg and plead, but they did let me in, and it makes for a nice background. I feel like I'm on CNN with one of those paper backgrounds behind the people that makes them look like they're calling in from some big city somewhere.
Yeah, we green screened all of San Francisco behind you. It's very cool. So also, I want to say sorry for last week's cancellation. I miscommunicated with my guests. I told them the show was November 29 instead of November 28, and then they are all like, well, why are you calling us today? Anyway, crazy that. And I hope you caught Aaron and me and our guest Peter in the big in-studio Petaluma show. If you haven't, go back and check that out. And I suspect that this show is actually going to be exactly the opposite in distance-wise. I think our guests today we actually have a 3-continent show going on. We've got somebody from Australia and somebody from South Africa coming on today. Who is that? That would be Steve Song, the project founder for the Village Telco project. Village Telco is a project creating technology to allow these small, cheap devices to essentially mesh network with each other to spread data and voice across an area that wouldn't otherwise be wired to be connected up both to the internet and at least just to each other. So sounds really exciting. We'll also be joined by Terry Gillett, who is working on bringing the same technology in a much better way to small enterprises in developed areas as well. So there's both an aspect of this of just sort of, bringing data to the common man, and also just being able to get stuff working better. At least that's what I'm seeing looking at the documentation coming up. That's our guest today. By the way, I also hope you caught my GMT to PST webcam that I did on New Year's Eve. I had a great time doing it. Had many hundreds of people watch it over the time that I was on. Actually, Aaron, do you know anything about Village Telco? And what do you think of today's show?
So I did a little research when we were getting ready to do the show. I hadn't heard of Village Telco, but I'm familiar with a lot of other projects, some in South America that are trying to do the same thing. Basically, taking making telecommunications easier and cheaper for the people that live there. And so this looks pretty interesting. It's a little different. It looks like it maybe uses some mesh network technology, which is really interesting. And it's also using a lot of technologies that people like to use in the open source community to do telecommunications, like asterisks and things like that. So it's going to be really interesting to see how they do this, how expensive it is, and what their strategy is for getting this deployed.
Great, great. Well, we will bring him on in just a second, but I have to bring an important message to you just before that. This episode of Floss Weekly is brought to you by Netflix. Netflix streams thousands of TV episodes and movies directly to you instantly, which means you save time, money, and hassle. There are several ways to instantly access streaming movies and TV shows with Netflix. You can watch Netflix movies and TV shows on your Mac or PC or iPad. You can watch on your iPhone, some Android phones as well. If you have a gaming console like an Xbox 360, a PS3, or a Nintendo Wii, you can watch Netflix right on your TV. And if you're not a gamer, you can watch Netflix on your TV with an Apple TV box or Roku box. They're inexpensive and easy to use. With Netflix, you can watch movies and TV shows instantly using any of these devices. And when you begin watching a movie or show on one device, you can finish on a different one. Whichever way you choose to access Netflix, you can watch as many movies and TV shows as you can at any time that you want. And you can cancel anytime. So try Netflix today for 30 days for free. Go to netflix.com/twit. Be sure to use that URL when you sign up for your free trial, netflix.com/twit. We thank Netflix for their support of Twit, and we hope that you enjoy watching instantly with Netflix. And now let's go ahead and bring on our guests. We'll first speak to Steve Song. Steve, welcome to the show.
Thanks very much.
And where are you speaking to us from? I hear it's a long ways away.
I'm in beautiful Cape Town, South Africa.
Wow, and for the power of Skype, you're brought right
the end of a sunny day.
Wow, very cool, very cool. And so I apologize in advance if the audience, if you hear a bit of scratchy sounds, because as you said when we were talking before the show, it's you have a limited bandwidth coming from there, correct?
Yes, in theory I have a 4 meg ADSL line, but somehow it doesn't seem to translate that once it gets through the international link.
Okay. Well, so I talked a little bit about the Village Telco project, and at least what I've understood of it so far in the intro to the show here. But why don't you give us sort of the 30,000-foot view of what the project's all about and how it came into being?
Sure. Well, my background is in international development and information and communication technologies. So I've been looking at the issue of the cost of access to both voice and data communications in Africa for some time, since the mid-90s. And the challenge is that not only getting infrastructure into poorer areas where traditional telecommunications companies are interested in going, but also in providing enough competition to drive down the cost of access. So both of those are challenges, and one of the big to breaking that is access to spectrum. So unless you have access to mobile spectrum, you really can't get into the market here in Africa, and that's a huge financial and also regulatory barrier. And one way around that is actually to use unlicensed spectrum. And unlicensed spectrum has, typically been used for, hotspot use predominantly in the industrialized world, but increasingly it's being seen as a backhaul solution. And we wanted to come up with something that would allow people to deploy their own voice and data networks to literally build their own telephone companies, albeit, small telephone companies.
Great. So that gives us a great overview, and I just realized I forgot to bring in the other guests. So sorry about that, Terry. Terry, welcome to the show. Terry Gillett, welcome to the show.
Morning.
Good morning. And where are we speaking to you from? Where are you speaking to us from?
Brisbane, Australia.
Wow. So we have a show that's spanning something like 17 time zones, I guess. Wow, that's probably a new record from last week where we're all in the same place to this week we're all spread out. And what is your relationship with the Village Telco project in a nutshell?
I became aware of the project about a year ago, and have been doing some contributions since then.
Okay, that's a nutshell. Only tiny description. Great. So let's go back to Steve for a second. Steve, so what is the basic mechanisms here, and how is it working? How are you using unlicensed spectrum to create this kind of infrastructure?
Well, all the technology to create wireless mesh networks and to use voice over internet technology has been available for some time. So there are a number of pioneering wireless mesh networks in Vienna, in Champaign-Urbana in the States, in Athens, and they've very successfully created, using open source software, mesh networking protocols that allow you to very quickly and robustly set up a wireless mesh network. But if you obviously some voice over internet technology to do that, and in order for people to deploy that simply, that can be quite challenging, because you either need a wireless access point and an analog telephony adapter and a phone, or you need a SIP phone and a wireless access point. And all in all, there were too many wires, too many sources of power for this idea to scale very well. So as we were looking at the challenge of, how do we make the concept of wireless mesh VoIP more viral, we actually came upon the idea of saying, well, maybe we need to build our own device that actually does this, as opposed to trying to sort of mash up or cobble together, existing commodity technologies.
Okay, and what was the result of that?
The result of that is a device we call the mesh potato. It's really just a combination of a Wi-Fi access point and an analog telephony adapter. It runs an open source operating system called OpenWRT, which is, I think, easily the most popular open source firmware for embedded devices. And in there we have common open source applications like Asterisk, like your standard sort of TCP/IP tools, but we sort of package them up to so that to the end user it looks like something that just plugs in and works.
Okay, so in terms of physical size, are we talking about something that's like the size of a bread box, or smaller or bigger? Is like an Arduino size, or what are we looking at? Oh, well, we're looking at it on the video, but some people are listening by audio, so if you could describe that would be great.
So it's a little bit bigger than my hand,
okay.
And it's enclosed in a sealed, weatherproof enclosure that's UV protected, weather protected, so it can be mounted outside. Which obviously to improve the range, because one of the challenges of Wi-Fi is that it doesn't like concrete or leafy obstacles very much. So getting the access points outside is quite important. Mm-hmm. And then you simply running the power and data down into the house to a telephone handset.
So in terms of like the connectors on the thing, you've got probably like a RJ45 and AC power and maybe a telephone line or an RJ11 jack?
That's right. Exactly. And so it has those three jacks on it, and you can power it by just one of those jacks. So you can actually run power over the telephone line, or more conventionally power over Ethernet. So you only need one cable going up to the device itself.
Ooh, even better, even better. That sounds great. So this is a small box, and I understand you're already manufacturing these and rolling these out in production?
That's right. Yeah, thanks to the designer, the hardware designer of the mesh potato, a brilliant engineer named David Rowe. He not only did the initial design of the mesh potato, but had an existing a relationship as an open hardware designer with the manufacturer in Shenzhen, and he introduced us to Atcom, who are the manufacturers. And interestingly, as a result of the completely open source nature of the project, we were able to very quickly get into a working relationship with Atcom as a manufacturer, because there was no sort of negotiation over, who holds the IP or, who will actually pay who for what. It was simply, we'll contribute the design to you, and, if you're prepared to manufacture it.
Wow, that's pretty amazing. So in terms of topology then, you would put one of these on the side of a wall or on a rooftop somewhere, and that would provide some sort of networking connection and maybe VoIP if, through over the RG11. You have to probably have these, like, what, every house or every other house to kind of mesh together in a neighborhood?
That's right. You, I mean, you're generally a maximum range of about 400 meters between between devices with clear line of sight. But that can, that can actually be less if there are obstacles in the way. And we'll often, use mix the mesh potatoes with other Wi-Fi technologies, such as devices with directional antennas to do sort of long shots or to bridge parts of the infrastructure where we haven't quite got close enough distance between 2 points.
Now, I understand that's not actually technically legal in the U.S. You can't focus the beams of Wi-Fi to try to get further range legally. Is that something you're running into in the U.S., or is that have I misunderstood?
Yeah, I mean, there are limits to what you can do. So certainly, I mean, there are a lot of directional Wi-Fi devices that that you can legally use. It's the combination of the power of the radio and the power of the antenna itself. So you can use a directional antenna, but you might have to lower the power output of the radio to get that sort of a combined output, the EIRP, which doesn't exceed 100 milliwatts, which is sort of the typical Wi-Fi standard.
Okay, and so let me try to understand also the idea of a mesh here too. I know a little bit about it from the OLPC. What you've got is a bunch of machines all talking to each other using standard Wi-Fi signals, but with a different protocol running on it, so they can kind of all talk to each other laterally. But somewhere in the network, then you have to have somebody who's actually on the internet then to get internet service, right?
That's correct. But actually, the way we've designed Village Telco is it can work without an internet connection. So the devices can actually phone each other or share data with each other fairly seamlessly without actually having an upstream connection. Now, of course, everything gets better once you have an upstream connection. And it only takes one device to actually be connected to the internet for all the devices on the mesh to be connected. And you can actually have multiple connections, and the mesh will automatically negotiate the best connection from where you are.
Wow, that's pretty amazing. So like you could have like a fast connection in some part of the network and maybe a slower connection in some other part, and as long as one of the two is up and running, you're good to go, right?
That's exactly it. And I think one of the interesting things for us is that we've recently changed mesh networking technologies. We're using a mesh networking protocol called Batman, but we've recently switched from the original Batman, which is a layer 3 internet mesh technology to a layer 2 mesh, which is very interesting because it really makes all the sort of weighing problems go away. And that's actually what Terry led us to in the project, and he'd probably be the better person to talk about it.
Okay, so the original Village Telco implementation used the layer 3 version of Batman, so that each device is dependent on its IP address to identify itself uniquely on the mesh. What we did when we wanted to add the data capability as well, and we wanted to run each point as a wireless access point, as well as a node on the mesh, we switched to the layer 2 protocol. And what that means is you can put a whole lot of these devices on the mesh. They all talk to each other with the mesh protocol, and then each device appears exactly as if it was a port on a conventional switch, so that it's no longer aware of the IP address of the traffic that's flowing on it. So you can then run multiple subnets over the same mesh, if that makes sense.
Yeah, it does actually. Now I'm a little curious about the. Is every packet then transmitted to all of the nodes, or is there some sort of reduced protocol there so it kind of knows where it has to go to?
Well, the mesh protocol itself works out where the data needs to go and routes it. And as Steve said before, it uses a routing algorithm to route the thing most efficiently through the mesh. And if it's going out to the internet, then it knows where the internet gateways are, and routes the most economic route through the mesh to get to the gateway.
So a bit like when you have a number of switches put together at the level 2, they sort of figure out, oh, this guy is on the left side of my switch, not the right side, and therefore if packets come in from the center, I know I only need to send it to the left side.
Yep. Now, I'm no expert on the Batman protocol, but that's pretty much my understanding of how it works under the bonnet. The key thing, though, is that with the layer 2, the whole mesh just acts as one great big layer 2 switch. So you can poke any bit stream in one port, and it'll find its way out to the appropriate port on whatever IP subnet that traffic's set up on.
And the great thing about that is that it actually makes the network effectively zero configuration. Because you simply plug the mesh potatoes in, they form their own wireless mesh, and they're transparent to whatever device you plug into it. So if you plug a PC or connect it to the wireless access point or into the internet port of one mesh potato, it transparently across the entire mesh and just looks for whatever layer 3 services, DHCP, etc., it can get from whatever is being served on the network. So it's been a boon to us, because it really has sort of taken, from a data perspective, all of the configuration issues away.
It's pretty important with a project like this, is that it's not like you have folks who are just kind of like me, who like to tinker and want this, want to get in there and reinstall the software and all this stuff, right? I mean, this is something that has to be, you drop it in place and it just works easily, right?
That's exactly it. And we're almost there on the voice side as well. So all you need to do from the voice, dial a 4-digit extension and to set the IP address from a VoIP perspective for the device, and then you can start calling. Each of the mesh potatoes can start calling each other, and we've designed it so that you can have full direct dialed numbers, but if you happen to be off the grid, you can actually just dial the IP address of the mesh potato that you want to connect to. And even better than that, you can just dial the last octet of the IP address that you want to connect to, and it'll ring that phone. So each of the mashed potatoes has a little stripped down version of asterisk in it that's got a dial plan that facilitates that. So for sort of quick setup small networks, it's all that are just local, that's also very quick as well. It's only when you start mapping the true telephone DIDs against the mashed potatoes that takes a little bit more effort.
Right. I love any project that has names like this: mesh potato, Batman. I mean, is the new version of Batman called Dark Knight by any chance? I mean, that would just be too cool.
So the only problem with the name Batman is, if you're ever searching for a technical conversation about the protocol, it's very hard to find anything.
Right, because the comic book Batman takes over the search results.
Absolutely.
That's funny. So how are these things getting deployed? I want to get into the open source angle on this as well. Right now we've been talking a lot about hardware and protocols, most of which are open protocols, but I kind of want to get a little bit more into the open source aspect of this. But first, how are these actually being deployed? Are they being deployed? Because I think there might be a misconception. You guys can clear this up for us. But whenever I hear someone say, "Oh, we're deploying these in sub-Saharan Africa," I think like remote villages and things like that. But is it also true that these might be deployed like in a big apartment building or something like that?
the goal of Village Telco was to aim for poor rural environments where the affordability of telecommunications infrastructure was at its lowest. But what we found is the uptake has actually been from more sophisticated users in more sophisticated environments. So housing estates, it's a very interesting solution for someone running in Southern Africa. We have loads of kind of rural day places where there are sort of multiple legitimacy and that kind of thing. Very appealing for that environment, and also appealing in kind of peri-urban areas where people simply want an alternative. So yeah, I mean, part of it is simply building critical mass, and right now we're open to helping anyone who's interested in using it for whatever application they have in mind.
Right, because I can imagine in a big building this would be a great alternative in terms of the way that we typically have done it in the past. Not even currently, but at least in the past, you'd run an individual line up to every apartment, every house, whatever. But that gets quite costly, and it's very difficult to troubleshoot when things go wrong. So if you do this all on a network and just give everyone a box and say, here, plug this in, and I'll provide a fat pipe for 500 apartments or something like that, I can see where this would be quite appealing to folks doing development in that area.
Yeah, probably. I mean, apartment are probably the least likely scenario, only because if you've got 500 rooms in an apartment building and you control all that infrastructure, you're off just running copper up the elevator shaft or something like that. So it's not there are trade-offs with every aspect of the solution, but what we found is that the technology seems to have its biggest appeal in where there are sort of separate buildings that you need to connect.
Right. We're talking about cost. What is the cost of one of these units? What's the cost per unit?
The retail cost there is $119 per unit, but in bulk that cost comes down to about $70 per unit.
So that's not too bad.
Well, it's hard at work on a next generation mesh potato, which we hope will be able to double the performance and drop the price by about 40%. So that's not really us. The evolution of technology, the Wi-Fi technology, just keeps getting faster and cheaper.
We've got some questions coming in from the chat room that I want to address too, but one more question that I had is in terms of this competing with cell phone technology, because in a lot of these countries, cell phone technology has leapfrogged standard traditional telephone copper line technology. So is this something that people are willing to use in the areas that you're going into, or are people like, nah, I'll just get a cell phone, or is it because they can't afford cell phones that this is a viable option? This doesn't compete with cell phones directly. It's a complementary technology, a bit like your fixed line phone is at home. So in sub-Saharan Africa, most people will have a mobile phone, but if they need to make a call, because all of the technology is caller pays technology, they will often that is, say, 40% cheaper to make calls rather than use their mobile phone to make calls. So people are very sensitive to cost. So if you can offer what is effectively a fixed wireless solution in their homes that offers them that can offload some of their costs and some of their calls, that's an appealing solution. And as the technology evolves, as people start to use smartphones, they can use smartphones to connect via Wi-Fi to this network and actually use it for both voice and data that way as well. So as you know, in the US, Wi-Fi networks are responsible for something like somewhere between 35 and 50% of the iPhone data traffic. We hope that Village Telco can actually offer that kind of
voice and data offload of mobile networks. So there's no way. I mean, we haven't deluded ourselves that we are going to touch mobile networks. Those are the most successful voice and data technology on the continent. But we can offer a complementary technology that can actually help to bring down costs and help to spread infrastructure in places that may not be economically viable for mobile operators.
Right. Now, you said these are using unlicensed spectrum, I believe, to make the connection between the devices, right? So I guess my question is, two questions really. Is that a legal problem anywhere to be using that? And then the other question is, did you have to specifically design the hardware with a special radio to be able to use this? Is there any design implications of using that particular spectrum, or was there, available radios already? Those components were already available to make use of that spectrum.
To answer your first question, is unlicensed spectrum problematic? Mostly no. Certainly here in South Africa, it's not a problem to use. It used to be licensed or occasionally illegal to use in a number of countries in sub-Saharan Africa, but increasingly that's as Wi-Fi has become ubiquitous and embedded in just about everything, it's become less of an issue. The only challenge you face really as an operator of a village telco is that you will have to get a telephone operator's license eventually. If your network grows to a certain size and you start charging commercially for services, then you have to get a telephone operator's license like anybody else. But in terms of the actual technology, it's bog standard Wi-Fi. The only sort of design differences are in the kind of antenna that we use.
It's probably worth pointing out too that you can run the firmware on any device that will run OpenWRT, and that covers a pretty wide range of devices. What's unique about the Mesh Potato is that it's added the analog telephone adapter into the hardware, but the rest of it you can run on any OpenWRT capable device with absolutely stock standard Wi-Fi.
Now, we haven't had OpenWRT on the show yet. It's actually been on my long list of people to finally bring on the show. Can you talk a little bit about what that is and what made that so revolutionary?
Okay, so OpenWRT has its origins in the Linksys WRT54G router device, which was running Linux, and there was some legal action around that, which resulted in the Linksys folk making available access to the firmware on that device. And out of that, the OpenWRT basically grew up as an open Linux distribution that you can flash onto a whole range of commodity devices. So while the original Linksys firmware is closed in the sense that you can't get a root login on it, with OpenWRT you have a complete access to the operating system that underpins the router. And now there's a range of routers that are actually sold commercially that run OpenWRT under the bonnet.
And this gives us things like nice setup menus and the ability to define, the network topology and local access policies and things like that, right?
Yep. So OpenWRT has a basic command line interface, which is just Linux as you would see it on pretty much any device. Obviously, there's a lot of scaled down stuff, but it's a reasonably complete shell. On top of that, they have a graphical user interface as well that allows you to do all of your router setup from a graphical user interface.
And I think the thing that we also want to make clear is, from what I understand, the Mesh Potato and other devices like this, there's no moving parts, there's no moving disk. It's all basically flash-based, correct?
Yep, absolutely correct. In fact, some of the recent work we've been doing is using some commodity devices from TP-Link which don't have the ATA voice component in them. But we can basically run this stuff now on a little box that's about 50 millimetres square. Runs on half a watt of power, and implements the whole thing. And in addition to that, it has a USB slot in the side of it, which a lot of the routers have now, and that allows you to plug in essentially unlimited extended flash memory for storing additional code and additional content if you want to use that to actually run local web content as well.
Cool.
I think
Steve
Steve
Sorry.
I think Steve has a device there that he can show you.
Yeah. So if you're watching the video, you can see this. If you aren't, it's a little box looks like 3 inches square. And how deep is it?
It's really about as thick as your finger.
Wow. Yeah, that's really small. And so that would be one of the nodes that would then be able to talk in a mesh way from one machine to another?
Yep.
Wow.
Yep, and that's correct. And to what Erin was talking about previously, if you want to set up a small enterprise type thing, you can basically put one of those at every desk in an organisation, and you have an instant network, no wires.
Now, again, addressing the issue from before, in terms of switching topology, of course, it figures out what's close by and what will eventually be upstream to the real bandwidth and stuff. What kind of latency does it introduce? Does it slow the pipes down? And how efficient is it being able to use the full Wi-Fi spectrum?
It's no different to what you get from a standard AP. So when you connect your laptop up to a standard Wi-Fi access point, you're basically running the same thing. The mesh doesn't actually give you any significant overhead.
I find that hard to believe, but I'll take your word for it. It sounds like it's got a good package.
So,
the guys who've done the protocol have done a heap of work on that.
Okay. Well, like I said, I'll take your word for it. That sounds pretty amazing. Now, this small enterprise campus network, SCCN project that you spearheaded and brought forward, this is related to that, right?
Yep. So the original firmware was designed to run predominantly the telephony side of it. So again, there's a couple of big deployments of that. One's in Dili in East Timor, and the other is in the Bokap township near Cape Town. And those networks have hundreds of nodes that just run telephony. So they're a community telephony network. What we looked at to go beyond that was to build in the data capability as well, which you can do on the original VT software, but you have to manage the whole network topology. So what we did with the SCCN firmware was go to layer 2, so that all the nodes on the mesh, from a data perspective, the whole mesh just looks like a great big layer 2 switch. So you can send any data stream across the mesh that you like. And the idea there was, whereas the original firmware scales out to hundreds of nodes on a mesh, the idea with the small enterprise network was to say, no, we're looking more for a mesh that might be 10 or 20 nodes. And that's where the small enterprise thing comes from. If you want to set up an office, or the other one that's very common is the emergency situation, where you want to go into an emergency situation and set up 10 or 20 people to be able to work with a telephone and a laptop and create this instant network in an emergency situation. That's a pretty good example. Then you can throw that whole thing together very quickly with essentially no configuration. You can gateway. You can provide 1 or 2 gateways into the network to take you out to the wider world. So that's really where the driver for that SCCN work came from.
So I could actually go out with my laptop, plug in my 4G card, and get online, presuming that at least some towers nearby were working for the 4G, and then reshare it using these mesh boxes to a small group of maybe 20 or 30 people. Now, obviously, bandwidth is limited there, but you're saying that kind of a deployment would be successful and work?
Absolutely correct.
Wow, that's incredible. And what's the cost point on these smaller boxes?
That's just a commercial commodity device that retails for about $20.
Oh, you're kidding. Wow.
It's, I mean, obviously it's not the same thing as the mesh potato. It's not in a weatherproof housing. It doesn't have the power over Ethernet and it doesn't have the telephone ATA in it. It's a USB powered device meant for internal use. But the other thing is, as Steve mentioned previously, it uses the next generation of Wi-Fi chips, and they provide a great deal more capability at a much better price point. So that's, in a sense, that works something of a prototype for the next generation mesh potato as well.
So what you'll do for the next mesh potato is add the asterisk and VoIP capabilities in the units as well then, right?
Yeah, well, actually, asterisk is already running on that little TP-Link box. The only thing it hasn't got is the physical circuit to allow you to plug a telephone in. But what we've done there is actually we've built in soft phone support, so that you can have a smartphone like an Android or an iPhone and install a soft phone application on that, and simply connect that into one of the nodes on the mesh. And then your smartphone acts as a telephone on the mesh. You can make local calls on the mesh as well as use the data link as well.
Fascinating. Steve,
SIP, right?
Sorry, go ahead. Oh,
Sorry, and that's using SIP. So as long as my phone supports SIP, I should be able to link in. Correct.
So the application that you would typically use on an Android phone would be something like SipDroid or 3CX, one of the standard soft phone applications. No modification to the phone, and just a standard SIP application. Yeah.
Wow.
Yep.
Steve, how has the reception been from the government and institution level as you're deploying Village Telco projects out there?
The reception from governments, we haven't approached governments directly. It is. I mean, there are lots of sort of universal service funds that exist certainly in South Africa and many other countries that have the intention of trying to extend rural infrastructure, but having worked in the domain of aid and international development, I was explicitly interested in making Village Telco a successful business as opposed to a sort of successful philanthropic enterprise. The technology ought to be good enough that people are willing to pay for it as opposed to being subsidized by government.
Well, I'm looking at it more from the perspective of regulation and interfering with what they think they want to do. Governments also love to control. So I'm wondering, this brings the power back to the people. I mean, how are governments reacting to that?
Well, in South Africa, we did have one network in a township south of Johannesburg that we built in partnership with a company called DABA. The regulator actually ripped out all of DABA equipment on what turned out to be a completely spurious claim of not having type approval for their. So we have pushback, but mostly we've had positive responses from government, and I think the big telcos just still quite correctly think we're still too small to worry about.
Well, hopefully, if your dreams come true, that will not be the case, right?
Absolutely, yes.
Now, as this gets deployed and rolled out, and obviously you've got a bunch of people working with you to create the software and update it and deploy it, are you finding that it's scaling well enough to do what you want to do, or are there? What's been the biggest challenge as you keep rolling this out?
I think the biggest challenge is creating an end-to-end seamlessly deployable solution. Mm-hmm. So having the technology work at every level. So thanks to Terry and others' work, I think the mesh potato itself is now a very elegant piece of technology. It's very easy to configure, and it works 90% out of the box with just minimal configuration in that's very understandable by the end user.
Where we still have a challenge is sort of integrating the voice network that on the Village Telco network into international voice networks. So if you want people to call you locally in South Africa, you've got to have a local South African telephone number so that people don't have to dial long distance. Mm-hmm. And that, the same applies for every country that you work in, which is nothing like the internet, right? The internet, an email address is an email address. But with telephone numbers, every country code and area code is kind of like a barrier that you have to transcend to make calls. So finding a way that we can easily federate calls across countries and do that in a way that is fairly seamless for the user, that's our challenge at the moment. So it's easy to get out and to make calls, but to have a local phone number is a pain.
It's interesting. We did interview somebody whose name I can't recall now, but their main piece of software was the addition to Asterisk to provide that sort of trunking and SS7 signaling and stuff so you can end up on real networks. I wonder if there's a way that two of you guys can get together and maybe share some technology.
We'd love to hear about it. I mean, the big deal is really not so much the technology, but the actual phone numbers. And the actual phone numbers are given out by the regulator. So that's quite a lot of work to get phone numbers for every country that can be then handed out, because you have to become a communication service provider in each country that you want to do that in. So in my opinion, the ideal thing would be for a company the size of Google to actually say, all right, we will federate VoIP services across all countries. Just connect to us, and you can start making local calls wherever you want. But obviously, everyone has lots of opinions about what Google.
More from the philanthropy point of view of this thing, I appreciate that you come from an aid background as well. Is this getting enough visibility of people that can fund it as fast as you want it, or is that still also a struggle for you?
We do have one investor. It's they're based in Boston, a company called Investor Development, and they've been a great seed investment partner. And we're just in the middle of what they call their beta program, which is a kind of trial phase with them to basically to see if we like each other and can grow together. And they've been fantastic partners, but we're definitely looking for more partners and investors.
Okay, I'm also, from what I heard you say earlier, you're really also looking to have each of these local Village Telco projects be self-funding by having a cheaper cost for getting online and getting on VoIP, but have it actually be a commercial project within each of these communities, correct?
That's right. We're trying to build a technology that will be very attractive to entrepreneurs, so that any local entrepreneur will see the opportunity to provide voice and data services locally, and that's kind of key to the Village Telco concept, is so that we would like Village Telcos to be run by local businessmen.
Cool. So you're providing the structure and the open hardware and software and manufacturing capability for the mesh potatoes and whatever the next generation is, and then they come in and go, well, let's see, if I deploy 500 units here to this small thing, I can probably make enough money to cover my telecommunication upstream cost and actually be a business for that then.
Exactly. Yeah. That's precisely the goal is to spawn entrepreneurship.
Very cool. Now, I've had a couple of questions in the chat room. People are going, can I get one of these? Can I get one of these? Is this something that I could buy retail right now, being in the U.S.?
Yeah, you can buy them online at store.villagetelco.com.
And is there anything like the buy one, get one program that the XO had? It seems like that might encourage more contribution.
We have talked about it, and I think it's a great idea, but we haven't actually implemented it yet. But we could do it very quickly.
And is there a list of places you'd like to fund if somebody had like an extra $1,000 and thought it would help out a community in South Africa? They could just simply buy the units for the community?
Absolutely. There are a number of initiatives that are part of the Village Telco community who would directly benefit from that kind of help. And we haven't made a list of them yet, but I mean, I feel kind of stupid now that you're asking me the question because it's a great idea.
Well, sometimes it's about synergy. Sometimes it's about what I've seen and what you've seen, and us having this conversation together. We both benefit. So I think that's part of why I actually do Floss Weekly, is to be able to talk to all you guys who are doing really great stuff out there. We're almost out of time. Is there anything I've left out of things that you want to make sure that our audience knows before we have to let you go? This technology offers huge potential to build sort of complementary infrastructure in places that really need it. And what we really would love to have is more people in the community contributing, testing the technology and contributing development. So if you'd like to make a contribution, please join us at the Village Telco Google group, and you'd be very welcome. Very good, very good. And also, oops, I scrolled down for the name. Terry, anything else last second here?
No, I think we've covered it off pretty well.
Okay, appreciate that. And I appreciate both of you guys coming on the show today to talk about the Village Telco project. I was really excited about hearing this. I heard a little bit about it at Fizzlay last year, and I just went, this is really amazing stuff to be able to just deploy these sort of self-configuring boxes and have them all start talking to each other, and all of a sudden everything's on the internet. So I appreciate the time you guys took today to talk about this project, and I'm sure you'll have a lot more interest because this show goes out to a lot of people. So I look forward to that. I hope so. Thanks, guys.
Many thanks for having us on.
Very good, very good. Well, that was, thank you. That was Steve Song and Terry Gillett, who are both big players. Steve Song, I think, is a project founder, yes, of the Village Telco project, and Terry Gillett offering a lot of additional things for that. What do you think, Aaron?
Well, I think it's great. I mean, this is the kind of thing that I used to have conversations when I got a chance with John Mad Dog Hall, who's also very interested in these types of technologies and the way that open source is enabling this type of technology. I mean, these are basically, it sounded to me like there was three projects, open source projects this was based on: the OpenWRT, the Batman, and the Asterix. And being able to bring those things together, and then the fact that it's open source really enables also the hardware aspect of it. Like he said at the top of the show, being able to go to the hardware manufacturer and say, look, we don't have to sign any special deals. It's all open source software that we're using. All we need you to do is put this radio here and so on. That really speaks to the power of open source software enabling this kind of communication mechanism for lots of folks.
Yeah, I like the fact that it's it's another way where open source hardware and software is really bringing the power of technology to a whole different group of audience. Because I mean, those of us in the States most of us can afford, a good laptop and good Wi-Fi antennas at home and things like that, and cable service or high-speed datacom. And we forget, although I'm constantly reminded of it when I travel around the world, that it's not everywhere. And so having something like this to be able to spread that out in a way that prevents us from having to, run a copper pair across, an entire trench of people in a row. It sounds like a great way to do this. I really like the fact that it's all self-configuring and stuff, and that it's cheap enough. I'm starting to wonder, why is anybody putting in cables in buildings being built today if there's this kind of technology that can just mesh everything together?
Yeah, exactly. I know that they tried something similar, I believe, in parts of Europe. I think France tried some mesh network technology that was similar to this. And so I don't see any reason why it shouldn't work. Like I said, especially for a large building where you've got the proximity already there. You can put one or two of these on each floor or what have you and connect everybody via SIP. It's basically what the large network providers are doing anyway. It's just that this kind of enables the local person to be able to do this as opposed to the AT&Ts and the Verizons of the.
I was also sort of amazed at the cheap cost of it. I was like, wow, I was expecting something in the $500 range. I guess I'm used to Apple's prices for routers. Actually, is the problem. So, but that's a whole other story. Speaking of whole other stories, we have a number of upcoming guests. There's the awkward transition for the week. Let's see here. Coming up next week, we have Dan Lynch is joining me. We're going to talk to Sam Aaron of the Overtone Project, which is apparently a musical editor, music generation device. So Dan, being a fellow musician, will be good to hear that. We also have some gaps in the schedule, but I'm hopefully going to fill everything. We're probably going to have a show every week, but I may not be here for all those. David Scholes can talk to us about Remind, which is a reminder memo program to tell you to-do list management, things kind of like that kind of stuff. David Carver and Sastry Maladi from the Turmeric Project, which is some software that eBay open sourced about something I should have looked up since the last time I did this show. Every time I keep saying, I'm going to find out what turmeric is so I can mention it, but apparently, just go look. It's on the website there. David Mirza, the Vegas security tester, pen tester, penetration tester, allows you to do an automated attack against your own boxes to figure out if there's some weakness that you overlooked as you were building it up. Lots more still coming up on the short list. Twit.tv/floss has the upcoming guest. Actually, there's a link from there to the spreadsheet that I use. If you see someone on that list that is way down the list, you can email them and have them email me, and I'll move them right up to the top of the list. So that's how to get your favorite project up on here. And I will be filling in probably the rest of the schedule. I'm just going to send another 20 emails again before the next week to be able to get some more people on there. We do Twitter and Identica on Floss Weekly, FLOSS I don't need to spell it. What am I talking about? If you can't spell the name of the show, you probably didn't find it already. So anyway, I use Twitter and Identica to be able to tell you when we have new guests being scheduled or the upcoming guest for the day, so you can follow us there to find out what's happening there. We tape live at 9:30 a.m. Pacific time. What's West Coast U.S. time. You can watch us live and go into a chat room, as you heard mentioned a couple times in the show. We have a chat room. We take questions from there frequently. And also, now they've just enabled the Floss Weekly, the Google Plus shared pages to have multiple managers. And that means I am finally going to fire up the Google Plus Floss Weekly page to start posting things there. And it'll probably auto-post to the Twitter like I have for my own personal stuff. So we'll be able to be able to see content there. I'll be forwarding things that I see interesting on Google Plus, sharing it directly through Floss Weekly as well, and I'm hoping that my other co-hosts do some of that as well. As soon as they get set up, we'll set you up, Aaron, soon, real quick. Also, Aaron, have you run across the Source Trunk podcast?
No, that's one that I haven't seen.
Well, I stumbled across it a couple weeks ago, and I downloaded the entire 160 back episodes, and basically every week he looks at 2 or 3 open source projects, usually desktop stuff, and reviews it and talks about how it's good for and what's interesting about it. He's not interviewing people. He's just basically reviewing the projects. And, a lot of people on this show have told me on this show that I'm not doing nearly enough desktop stuff. And it's because I don't use a Linux desktop. So I don't have, the impetus for that. And, the way you get anything on this show is you basically have the project leader email me. But that hasn't happened a lot. But if you do want desktop projects, desktop reviews, go check out sourcetrunk.com. The host, Dimitri Larmuso, I'm probably mispronouncing that, has a very strong Belgian accent. So for a long time I thought he was saying the author of this thing, but he's saying the author, the guy who wrote it. So the author of this program, what the hell is that? Anyway, so go check that out, though. I've been looking at the back catalog, and it's just been really wonderful. He does a really great job with the reviews, and he also reviews a Belgian beer every week. So it's a great combination of him sipping in the background, describing a Belgian beer, as well as talking about 2 or 3 interesting source projects each time. Boy, I'm running along on the show. Sorry, I'm Merlin, M-E-R-L-Y-N, on Twitter, Identica, and I've also got a Google Plus page I use quite frequently. If you followed Merlin, you would find it I'm going to be doing tomorrow night. I will be at the Unix Users Southern California. I'm going to be talking for them the Git talk. I'm going to do a 2-hour intro to Git. If you're in Southern California, you can check that out at uuasc.org/LA. I'll be in Daytona Beach next week, but I'll still be doing a show. I'm going to be in a cruise in 2 weeks, so I'll actually be away from the show for a week. And that's enough plugging for me. We're really running over there. So, Aaron, anything you want to plug before we wrap this up?
Yeah, if you're going to be at Scale, be sure to look for me down there. I'll be doing a podcast from Scale again this year. So if there's, I would say a similar thing. If there's somebody or some project or something that you know of that's down at Scale that you think would be really interesting, or an event that's going on that would be really interesting to have on my podcast, thesourceshow.org, just come up and let me know, or just come up and introduce yourself if you see me. Don't be shy. I'm very shy, but you don't have to be shy. Just come up and say hi, and maybe we can get a drink or something like that. So be sure to look for me at Scale. And I think, Randal, you're going to be there the last day still. Is that correct?
Yeah, I'm basically flying in right around 9 p.m. on Saturday, so I'll be at the hotel starting at 9:30. I'm actually spending the night there. That'll be my home away from home for that day. And so you'll probably find me, as you often do on Scale days, you'll probably find me at 9:30 in the bar, in the hotel lobby bar there. So I'm going to be there through about 4 o'clock the next day. So if you see me and come up, say hi, please. And I know people find it hard to believe, but even though people like you and I, Aaron, are on a podcast and talking to tens of thousands of people every week, I consider myself shy as well. So if I'm not running around being gregarious and introducing myself to you, please come over and say hi to me. I'm happy. I don't bite very much. Come over and say hi. So Aaron, are you sticking through for the whole weekend then too?
Yeah, I'll be down there for the whole weekend trying to record all the different events that are going on. It's the 10th year of Scale, so I think they've got a lot of special guests and special things going on. So I'm going to try to capture as much as that as I can in my. But I do like to get some good interviews too while I'm there. So last time I interviewed. I hate it when I can't think of names, but the CEO of Canonical. I can't remember her name, but I interviewed her. Interviewed a number of other folks. So I get some pretty good interviews while I'm down there. But I love to interact with everybody as well. So it'll be a lot of fun.
Sounds great. We're running a little long. So Aaron, once again, thank you for co-hosting the show today.
Anytime.
Very good. So I hear the music coming up, and of course that's always a signal to say it's time to say. How am I going to get to this? It's time for me to say thank you for watching the show, and we'll see you all again next week on FLOSS Weekly.